Hello students, today in this particular session we are going to see the concept of structural analysis. And which concept we are talking about? We are talking about the indeterminacy. Now hello everyone, I am Mukesh Rai and I am going to discuss with you the most important topic of structural analysis, that is indeterminacy. Now moving towards the indeterminacy, first we will discuss what is the syllabus of AE exam. Now this is the complete syllabus of your AE exam, starting from the statically indeterminate structures, strain energy method, moving load and influence line. It means that we are talking about the influence line diagram. Next is the arches. Now here cable is not given, it means that cable is not included in the syllabus. Next is the method of structural analysis, means slope deflection method, moment distribution method, we called it as MDM method. Then Clapeyron's theorem, that is three moment equation. Then Carney's method of analysis. So this is the complete syllabus of structural analysis, students. Okay, now students, if I just want to ask you one question, that you had already completed the strength of material or solid mechanics in your colleges, as well as you had done the complete study of structural analysis in your college. So can you just please tell me what is the major difference between the solid mechanics and the structural analysis? Can you please tell me? No? Now listen. Now if we are talking about the solid mechanics or strength of material, generally it comes nearly in third semester, and we can say that in the complete strength of material portion, you had already studied only which particular beams or which particular structures, that is the determinate structures. Now what is determinate structure? We will discuss that in detail, okay? But first we should know that why we are going to use the structural analysis methods, or in which type of structure we will apply the method of structural analysis. Okay, so in solid mechanics or strength of material, we will only deal with the determinate structures. Whereas in case of structural analysis, we are more focused towards the indeterminate structures. Clear? Now what is determinate and what is indeterminate, we will discuss that in detail. Okay, now before that I just want to cover some basic concepts of structural analysis, then we will move towards the determinacy and indeterminacy. Okay students, now we will start with the basics of structural analysis. Now students, if we are talking about the basics of structural analysis, we have to go towards the engineering mechanics portion. Now in engineering mechanics, we had studied various types of support. So can you just please tell me what are the different types of supports we are using in our civil engineering structures? Yes, can you please tell me what are the various types of supports which we are going to use or which we are already using in our civil engineering structures? Definitely the first one is fixed support, the next one is hinge support, and the third one is roller support. So any other support? Oh sir, simply supported beam. It is a beam, it is not a support, it's a beam. So sir, is there any other type of supports also exist? Yes, there are more than these three particular supports which exist in the structures. The first one is guided roller. Now we will bifurcate this guided roller into two portions. The first one is vertical guided roller and the second one is horizontal guided roller, and the third one which we have to deal with is the simple support. Not simply supported, it is a simple support. So sir, can we discuss that particular thing in detail? Yes, definitely. Now we will start with the first support, that is the fixed support. Okay students, now just see here, I had just prepared an animated view of fixed support. Now what happens as soon as I apply a horizontal load here, now as per the Newton's third law of motion, to every action there is an equal and opposite reaction, and here reaction comes on the support only. Okay, now first we will discuss that particular thing in detail, starting from this particular thing: horizontal load applied, horizontal reaction. Again horizontal load, horizontal reaction we will get. Vertical loading, we will get vertical reaction, and for a moment we will get a moment of resistance. Okay, now what is the practical example of that, or how can we just make this support in our structure? This type of support is generally prepared in this way. The first type of fixed support diagram is this one, and the another one is this one. Now, how many reactions are possible, sir? The first one is vertical reaction, which is possible. The second one is horizontal reaction, which is possible. And the third one is moment or moment of resistance, which is possible. So, if we are talking about the external support reaction, generally it comes as three. The first one is vertical reaction, the second one is horizontal reaction, and the third one is moment. Now, if we just shift that entire reactions here, vertical reaction, horizontal reaction, and the moment of resistance. So if we are talking about a fixed support, then on each and every fixed support there exists three types of reaction. The first one is horizontal reaction, the second one is vertical reaction, and the third one is moment of resistance, students. Okay, so just remember this particular thing, that if we are talking about the external support reaction on the fixed support, it generally comes out as 3. So sir, can we see the practical examples of this? Yes, definitely. These are the practical examples of fixed support, students. You had seen these types of structures on railway station or near to railway station. This is the fixed support. This is the fixed support. Okay, if we want to just displace this particular structure in horizontal direction, it will give us the resistance or the reaction against our applied loading. If we want to just move this particular structure in the upward direction, then it will give a reaction in the downward direction to counterbalance our load or force. Okay, now if we just try to rotate this particular structure by applying a moment, it will give a moment of resistance which will try to counteract that particular moment which we had applied on that structure, students. Okay, students, so till now I had explained you the fixed support and its real examples. Okay, sir, is it necessary to understand all the supports here right now? Yes, it is very important to understand all the supports right now. Why? Because we have to use each and every support reaction in case of indeterminacy. And if we want to cover the indeterminacy in a very good manner, then we have to cover all these supports, students. Okay, now moving towards the next support, that is the hinge support. Now again I had prepared here a structure which is supported over the hinge support and the roller support. Now you have to concentrate here only on this support, that is on this support you have to concentrate, student. Okay, now students, kindly focus on this particular support. I am just going to apply a vertical loading here and just see how many reactions comes on this particular support. Just see this particular support. Okay, I had applied here a vertical load, so vertical reaction and horizontal reactions comes into the picture. I had applied a vertical load here, so vertical reaction and horizontal reaction comes into the picture, but no movement is occurring or no movement is coming here in the form of movement of resistance or in the form of reaction. Why in this case no movement is coming here in the form of resistance? Because it will allow rotation of the structure. How, sir? Just see again this particular animated view. Just see here. Now when we applied the load, just see, it will allow the bending of this particular beam. It will allow the bending of this beam. It means that rotation is allowed here. Rotation is allowed here, and if rotation is allowed, if this beam is free to rotate, then how the movement will exist here? Okay, so at every hinge support, there exist only two reactions. The first one is vertical reaction and the next one is horizontal reaction, students. Okay, in this way we will show the hinge support in our structure. Okay, or like this. Okay, in certain structural diagrams it will appear like this also. this is also a hinge support. This is also a hinge support. Here we have the vertical reaction and here we have the horizontal reaction. So if we are talking about the hinge support, then only two external support reactions exist here. Only two external support reactions exist here. Which one? The horizontal and the vertical reaction. That's it. No movement exists here on this hinge support. Clear, student? So on fixed support we have three reactions: horizontal, vertical and movement, whereas in case of hinge support we will have only two reactions, that is vertical and horizontal, students. Now, sir, is there any real example or real life examples of hinge support exist here? Yes, definitely. These are the real life examples of hinge support. Now, if you just see this particular diagram of seesaw, okay, at this particular joint, we will have a hinge support. Similarly, in our laptop we have the hinges which will just allow the screen to rotate freely. But if we just try to pull out that screen from the laptop, it will not comes out. Why? Because it will give us a reaction in the downward direction. If we just try to pull that screen in the horizontal direction, it will not comes out. Why? Because it will give a reaction in the opposite direction. So at every hinge support we have only two reactions, that is vertical reaction and horizontal reaction, student. Similarly, in our doors we will have hinges just like this. Due to which what happens, we will have a free rotation of the door. Because rotation is allowed here, that's why movement is equals to 0 here. Okay. Similarly, in case of bridge which will open from the center portion, which will allow the movement of a particular shape. Okay, so to just rotate that particular bridge at the springings, we have to assemble here a hinge support. Okay, students, clear? Done. Now moving towards the next support, that is the roller support. Now again we have the same beam which will rest over one support in the form of hinge support, and the another support is roller support. Now you have to see this support only. Okay, I am again going to apply here a vertical loading. Just see the diagram. If we apply a vertical loading, it will rotate as well as it will move in the horizontal direction. Just see again, students. If we apply a vertical loading here, it will rotate as well as it will move in the horizontal direction. It means that it is free to rotate as well as it is free to move in the horizontal direction. But if we apply any vertical loading here, it will give us a vertical reaction. So on the roller support which will appear like this, we will have only one reaction that will exist in the form of vertical reaction, and this is the roller support which will have only one reaction, which we called as vertical support reaction. Okay, student. Now we will see some real life examples of support. Now this is the real life example of roller support, student. Now if we have seen the trolley bag, it will have roller support here which will allow the horizontal movement of that particular trolley bag very easily. If we just try to rotate that trolley bag in the circular motion or in the circular direction, okay, it will easily rotate because rotation is allowed, horizontal movement is allowed. Now if you just lift that particular briefcase in the upward direction, there exists always a downward reaction which will try to bring that particular briefcase in the downward direction. So on every roller support we have only one vertical reaction, that is only in the vertical direction. Okay, so till now we had covered our basic supports, that is the roller support, fixed support and hinge support. If we are talking about the fixed support, we have three external support reaction, that is horizontal reaction, vertical reaction and movement. In case of hinge support, we will have only two reactions, that is vertical reaction and horizontal reaction. In case of roller support, we will have only one reaction, that is in vertical direction. That's it. Now we will move towards some special cases of support, starting from the guided roller support. Okay, suppose, student, if I have a sliding door here or a sliding gate here, and if I just try to pull that particular sliding gate in the horizontal direction, it will move very easily. But if I try to just move that particular sliding gate in the vertical direction, it will not move because it will give me a vertical reaction in the downward direction. Similarly, if I try to rotate that sliding gate in the circular direction, it will not rotate. Why it will not rotate? Because rotation is not allowed in case of guided roller. Okay, so you have received a very good concept here that at each and every guided roller we don't have any rotation which is allowed. So sir, on guided roller how many reactions are possible? One, that is if we are talking about the horizontal guided roller, which will appear like this in our structure, so horizontal movement is allowed, so horizontal reaction will not exist here, but vertical reaction will exist as well as moment of resistance will exist here. So in case of horizontal guided roller, we will have two reactions. The first one is vertical reaction and the second one is moment. Now this is a case of vertical guided roller. This is a particular window. If we just open the latch from here, it will freely fall under the gravity. What does it mean? It means that here vertical movement is allowed. But if I try to just pull that particular window in the horizontal direction, it will not come. Why? Because it will give me a reaction in the horizontal direction. If I just try to rotate that window in the circular direction, it will not rotate. Why? Because it will give me a moment of resistance, that is the resisting moment. So in case of vertical guided roller, students, we will have a horizontal reaction as well as we will have a moment of resistance. So at each and every vertical guided roller, we will have only two reactions, that is horizontal reaction and moment. Clear, student? So if anyone asks you that how many reactions are possible in the guided roller, always two reactions are possible. Now which two reactions will depend on the type of guided roller. If it is a case of horizontal guided roller, then definitely vertical reaction and moment of resistance will be there. If we will have a vertical guided roller which will appear like this in our real life structures, so we will have horizontal reaction and moment there in the form of reaction. Clear, student? Now the last type of support is the simple support. Now what does the simple support mean, sir? Let us suppose if we had capped a beam, this is a beam, if I just cap that beam on a particular support like this only, okay, I had not fixed that particular beam on this support by any means. I had just capped that beam over this support, not fixed that beam on that support. Okay, I had just placed that beam directly over that support but not attached with anything. Now what does happen here? Let us suppose if this beam wants to move in the horizontal direction, it will easily move in the horizontal direction. If we try to rotate that beam here, it will freely rotate. But if we try to displace that beam in the vertical downward direction, it will not move in the vertically downward direction. Why? Because we had applied a reaction in the upward direction. That's why here no rotation is allowed. Here no vertical movement is allowed because we will have a vertical reaction here. Rotation is freely allowed as well as horizontal displacement is also allowed. So we will have, in case of simple support, we will have only one reaction, that is only the vertical support reaction. Okay, students? Now this is the shape and the reaction which we have to write here based on the type of support. Now as we had already discussed in our previous concepts, the fixed support will have a shape like this, either this or this one, and here three reactions will exist, that is the external support reaction, the horizontal reaction, the vertical reaction and the moment of resistance. Okay, student? In case of hinge support, it will appear like this, it will appear like this, it will appear like this, or it will appear like this. Okay, in which we will have only two reactions. The first one is horizontal reaction and the second one is vertical reaction. The third one is roller support. Now if we have a roller support, it will appear like this. It will appear like this, and we will have here only one reaction, that is vertical reaction. Okay students, now if we are talking about the vertical guided roller, it will appear like this, it will appear like this. Okay, and here we will have only two reactions, that is horizontal and movement. In case of horizontal guided roller students, we will have this type of support in our structures, and we will have here only two reactions, that is vertical reaction and movement. And the last one is simple support, where we will have this type of support. The beam is kept over a support and we will have only one reaction in upward direction, that is one reaction in vertical direction. So these are certain important support which we had covered till now. So sir, is it important to cover all this support? Yes, very important, because now I am just going to discuss with you the indeterminacy. But before indeterminacy, we have to discuss the what? Equilibrium condition, students. The equilibrium condition. Now what does the equilibrium condition means? Yes student, we had already studied this particular concept, that in our structures we will have three equilibrium conditions. We will have three equilibrium conditions. The first one is summation of all the forces in the vertical direction is equals to 0, summation of all the forces in the horizontal direction equals to 0, and summation of moment about any point in the body equals to 0. If this condition exists, then our body is in equilibrium. We had already discussed that particular thing, okay, as well as you have the idea of particular this equilibrium condition. But what does the equilibrium means? Let us suppose this is a structure which is kept here. This is a structure which is kept here, and this particular structure will have x coordinate, y coordinate and z coordinate. Okay, now some system of forces are acting here in the horizontal direction also, in the vertical direction also, as well as movement is also applied on this particular structure. Now if this structure will not change its basic coordinate, if this structure will not change its basic coordinate under the action of forces, then this body will be in equilibrium. What does it mean? Let us suppose if horizontal forces is acting, and let us suppose if left to right and right to left force of equal magnitude will comes over this particular structure, then both will cancel out each other and the net effect of both these forces will be 0, and the body will remain stable here only, it will not move in any of the direction. Let us suppose if vertically downward force and vertically upward force of same magnitude is acting on this particular structure, both will cancel out each other and again the body is stable here, so the body will be in equilibrium. Let us suppose if clockwise movement and anti-clockwise movement of same magnitude is acting over this particular support or on this particular structure, then what happens? Anti-clock and clockwise movement will cancel out each other and we will have a net movement which is equals to 0, body will remain stable. So what does it mean? If all the three conditions exist here, the body will not change its basic coordinate, and this is the condition of equilibrium, students. This is the condition of equilibrium. Okay, so now if we want any of the body to be in equilibrium, we have to follow all these conditions. What does it mean? It means that if a body is in equilibrium, then the summation of all the forces in the vertical direction is equals to 0. The summation of all the forces acting in the horizontal direction is equals to 0, and the moments which is acting on the body, the net sum of that moment will also be 0. Then we call this structure as a equilibrium structure or a structure which is under equilibrium. So sir, how we will just find this particular thing? Let us suppose students, we will have a beam here, okay. Now we have reactions here, which is 20 and 20 kilonewton. We will have a loading here which is 40 kilonewton, Okay, just see here, we will have a horizontal force. Okay, I will just make the horizontal force by another color. Let us suppose if this is the horizontal force of 10 kilonewton, and if this is a force of 10 kilonewton, let us suppose if there exists one movement of 5 kilonewton meter, similarly an anti-clockwise movement of 5 kilonewton meter will exist here. Now we have to find whether this body is in equilibrium or not. So what we will do here, we will just follow these three conditions. Now for finding all these three conditions, we have to assume here certain sign convention. Now all the forces which is moving from left to right is considered as positive. All the forces which is moving from right to left is considered as negative. Upward forces positive, downward forces negative. Okay, clockwise movement positive. Okay, anti-clockwise movement negative. Okay, so these sign convention we have to follow here. Now student, just see here, if we are talking about the net sum of vertical forces, so 20 force is acting in the upward direction. As per our sign convention, it is positive. So 20 plus, similarly plus 20. And we will have a downward force of 40 kilonewtons, so minus 40 will be there. Net sum will be 0. Similarly, summation of forces in the horizontal direction, so left to right positive, left to right 10 kilonewton positive, right to left 10 kilonewton negative, so this will be 0. Similarly, we have the net movement acting on the beam. 5 kilonewton will be acting in the clockwise direction, which we considered as positive, so plus 5. And similarly, anti-clockwise movement of 5 kilonewton is acting on this beam, which is considered as negative, and this sum will be 0. So if all the three components, or we can say that if all the three elements, it is summation of vertical forces equals 0, summation of horizontal forces equals 0, summation of movement about any point in this structure is 0, then this particular structure is known as, the structure is under equilibrium. Structure is under equilibrium. Okay students, done. Now you got enough idea about the support reactions as well as the equilibrium condition. Now we will move towards the next portion. Now let us suppose I will give you one structure here. I will give you one structure here which will just like this, Let us suppose here we will have a force of W kilonewton. We will have another force here of W kilonewton. Force or load, we call it as load. Okay. And we will have a distance between these two loads, that is L. Let us suppose we will have another load of W kilonewton exist in the horizontal direction, and another load of W kilonewton exists here in the horizontal direction, and the distance between the two load is again L. Now tell me whether this body is in equilibrium or not, student. Just tell me whether this body is in equilibrium or not. Just solve it. Okay students, now just follow one by one each and every step. First we will find summation of forces in the vertical direction. Now this will be considered as positive W, this will be considered as negative W, and this will be 0. So this body may be in equilibrium if the second and third condition also becomes equals to 0. Now we have to check the net forces in the horizontal direction. Plus W minus W, this will be equals to 0. Now if we want this body under equilibrium, then third condition must be equal to 0. Now what we have to do, we have to find here the moment. Now this W and this W will try to make a couple like this. This will make a couple like this, which will comes in the clockwise direction of intensity W into L. Similarly, this W and this W will create again a clockwise couple of intensity W into L. Now, if we are talking about the net movement on this body, then this will be WL in clockwise direction considered as positive. Again WL in the clockwise direction. So this body will have a moment which will be equals to 2WL, which is not equals to 0, student, which is not equals to 0. So third condition fails here. So this body is not under equilibrium. So we can write it as body is not under equilibrium. Body or structure is not under equilibrium. Done, students? So very easy question, na? Very easy question. Now let us take one more question here, students. Suppose that this is a structure. This is a structure, and here a W kilonewton load will act in the upward direction, and here a W kilonewton load will act in the downward direction. And this is the distance between the two loads, that is L. Similarly, another load of W kilonewton will exist here, and another load of W kilonewton will exist here, and both this load will have a distance of L meters. Now just check whether this body is in equilibrium or not, students. Just check. Done. Now just find all the three conditions here. If we are talking about the net force in the vertical direction, it should be W positive, W negative, W minus W. It will be equals to 0. Summation of forces in horizontal direction plus W minus W, both will be equals to 0. Now net moment we have to check, because the above case fails here only. Okay, now we have to check this particular case also. Now this W and this W will try to make a anti-clockwise couple of W into L, This will try to make a anti-clockwise couple of W into L, and this W and this W will try to make a clockwise couple of W into L. Now if we are talking about the net moment acting on this particular structure, that is clockwise WL and anti-clockwise WL, and both will cancel out each other, and we will have net moment equals to 0, student. So in this particular case, all the three conditions satisfied. So this body or this structure is under equilibrium. So body is in equilibrium. Body is in equilibrium. Okay, students? Done. Done. Now I will give you certain question to practice here. Just solve one by one. Okay, then we will move towards the main portion of indeterminacy. Okay, now just solve here, na? Let us suppose we will have a beam here. We will have a beam here which will have a hinge support here, and we will have a roller support here. Roller support. Okay, and this particular beam is subjected to a general loading. Generally inclined loading is called as general loading. So let us suppose if this particular beam is subjected to a general loading of intensity 10 kilonewton having an angle of 30 degree. Now just find here, students, the number of support reactions as well as the number of equilibrium condition. Find here. So we know that at hinge support we will have two reactions, that is in vertical direction and horizontal direction, and on roller support we will have only one reaction, that will in the upward direction. So if we just name it as A and B, then this will be known as VA, this will be known as VB, that is vertical reaction at A and B, and this is horizontal reaction at A. So how many support reactions exist here? That is 3. Now how many equilibrium conditions exist? That is 3 again. So now let's move towards a basic concepts of maths. If we have x and y as unknown in any equation, if we have x and y as unknown, and if we have to find the value of this x and y, then we need at least two equations, because we have two variables. Similarly, if we have x, y and z as variable in our equation which is unknown, that is x, y and z, then we will require at least 3 equations to solve that particular variables. So it is very clear that if the number of unknown is 2, then we will require 2 equilibrium equations or 2 equations to solve that. If we have 3 unknowns, then 3 equations will be required. 4 unknowns, 4 equations. 5 unknowns, 5 equations to solve that particular variables. Now here in this case we have 3 unknowns, VA, VB, HA. We have 3 unknowns, VA, VB, HA. we have three equation of equilibrium, that is summation fx equals to 0, summation fx equals to 0, summation of fy equals to 0, and summation of moment about any point in the structure is 0. Now we have three unknown, we have three equation, so it is practically possible here to find all these three unknowns. So now we will just go with the flow with a particular definition, that if we are able to find, just listen students, if we are able to find all the unknowns in a particular structure by the condition of equilibrium, that particular structure is known as determinate structure. I am again repeating the entire definition. If we are able to find all the unknowns with the equilibrium condition, then it is a determinate structure. And if we are not able to find the unknowns present in any structure with the equilibrium condition, then that type of structure is known as indeterminate structure, students. Clear? So how we will find here? Let us suppose we will just subtract both this value and this comes out as 0, 0. It means that it's a case of determinate structure. It's a case of determinate structure. That's why this beam is known as simply supported beam, and it is a determinate beam. That's why we had solved these type of question in strength of material or solid mechanics. Done, students? Now take one more example of this. Now just take one more example of this. Now students, I had given you two similar beams, that is cantilever beams, but the type of loading is different. Okay, now just find whether this body is determinate or whether the structure is determinate or not. Okay, you have to find both the cases separately. Just try to solve. Now students, if we just make the reactions here, then now this particular loading, that is inclined loading, will have two components. One component will be in downward direction like this, and another component will be in horizontal direction like this. Okay, now to just balance this vertical reaction, we will have vertical loading, we will have a vertical reaction. To balance this horizontal loading, we will require a horizontal reaction here, and moment of resistance will always exist in case of fixed support, whereas in this case we don't have any horizontal loading. So if no horizontal loading is given, then we don't have any horizontal reaction which will exist on the fixed support. Okay, if in case of vertical loading, that is no horizontal load is given, then we don't have any horizontal reaction here. Okay, so to balance this vertical reaction, vertical loading, we will have a vertical reaction. To balance this vertical load, we will have a vertical reaction, and moment will always exist in case of fixed support. So here we will have three external support reaction. Here we will have two external support reaction. Okay students, now kindly listen here. Now if we are talking about the equilibrium condition in both the cases, in this case there exists three equilibrium condition, that is summation of forces in vertical direction equals to 0 because we will have vertical reaction, summation of forces in the horizontal direction equals to 0 because we have horizontal forces also, and summation of moment about any point in the structure equals to 0. But in this case we will have only two equilibrium equations, that is summation of forces in vertical direction equals to 0 and summation of moment about any point equals to 0. We don't have the third equilibrium condition, that is summation of forces in the horizontal direction equals 0 because we don't have any loads in the horizontal direction. We don't have any type of loading in the horizontal direction or any type of forces in the horizontal direction. So now from here, just remember one thing, if we have general loading case, then always we will have three equilibrium equation in case of beams. If we have vertical loading case, as shown in the second diagram, we will always have two equilibrium equation, that is fixed for all the types of beam, beams. Okay, now here the number of unknown is 3, the equation is also 3. So if we just subtract Re minus S, then this will becomes 3 minus 3, which will be equals to 0. So this is a determinate structure. Here we will have two unknowns and two equation, again 2 minus 2 equals to 0. This is also a determinate structure. That's why we had studied this type of structures in the strength of material or solid mechanics, that is the cantilever beam, which is a determinate structure, students. Clear? Now you clearly get an idea of which structure is determinate and which one is indeterminate. Those structure in which we will find all the unknowns with the equilibrium equation alone are known as determinate structure, and those structure in which we are not able to find the number of unknowns from the equilibrium condition alone is known as indeterminate structures. Clear, student? Now it is clear. This is the basic of determinacy and indeterminacy. Okay, students? Now we will start the indeterminacy. Now, students, if we have to find the indeterminacy or the definition of indeterminacy, we have to understand certain terms here. That is information. Now, what does this information means? It is bifurcated in two parts. The first one is forces, and the second one is movement. Forces we called as either loads or moments, and the second one is movement, that is displacement or rotation. Done. So if I am just talking about the information means what? It is the sum of forces as well as the movements. Forces means what? We have external forces and the internal forces. What does external and internal forces means? Just see here. Let us suppose if we are talking about the external forces in this particular beam, then we are talking about the external support reactions. That is vertical reaction here and horizontal reaction here, because we have a general loading. Okay, we have three external support reaction here. We have three external support reaction here, students. The first one is VA, next one is VB, and the third one is HA. Now, if we just cut this beam from the center, three internal forces will be there. If we just cut this particular beam from the center, we will have three forces which is shown here on this cutted portion, which will be appearing like this. The first one is shear force, the next one is axial force, and the third one is bending moment. So these are the internal forces. These are the internal forces in any of the beam. Internal forces. Okay. Now you got a clear-cut idea of what are the external forces, that is the support reactions. What are the internal forces, that is the internal reaction, that is axial force, shear force, and bending moment. Okay, students. Now just see the definition. Okay. Now what does indeterminacy means? The number of unknown information. The number of unknown information which cannot be solved with the theory of equilibrium alone is known as indeterminacy. What does it mean? If we have any unknown external or internal forces, if we have any unknown movement which cannot be solved with the theory of equilibrium alone, then this is known as indeterminacy. So this is a very big definition. Can you just simplify this particular definition? Yes, definitely. Next one is kinematic indeterminacy, denoted by dk, d suffix k. Now what does kinematic indeterminacy means? The number of unknown movements, in a structure which cannot be solved with the theory of equilibrium alone. What does it mean? If we are not able to find the displacement and rotation which is in the form of unknown present in the structure by the theory of equilibrium alone, then it is known as kinematic indeterminacy. It is known as kinematic indeterminacy. Means in case of kinematic indeterminacy, we will have unknown in the form of movements, which cannot be solved with the theory of equilibrium alone. Done. Now moving towards the next portion, that is static indeterminacy. Now what does static indeterminacy means? Movement is complete. So number of unknown forces. What is unknown here? Forces. Unknown forces. Now this forces will be the sum of external reactions as well as the internal forces. External forces as well as internal forces. So number of unknown forces which cannot be solved with the theory of equilibrium alone. Number of unknown forces which cannot be solved with the theory of equilibrium alone is known as static indeterminacy, denoted by D suffix S. Now if we further bifurcate this, then we will have external static indeterminacy and internal static indeterminacy. What does this mean? If we have unknown external forces, that is in the form of support reactions, if we have unknown external forces which cannot be solved with the theory of equilibrium alone, it is known as external static indeterminacy. And if we have internal forces as unknown which cannot be solved with the theory of equilibrium alone, it is known as internal static indeterminacy. So if we have unknown external forces which cannot be solved with the theory of equilibrium alone, it is known as external static indeterminacy. While if we have unknown in the form of internal forces, that is axial force, shear force or bending moment, which cannot be solved with the theory of equilibrium alone, then it is a case of internal static indeterminacy, students. Clear? Got a clear-cut idea of what does the static and kinematic indeterminacy means? Now we will focus towards the external static indeterminacy. How we will find the external static indeterminacy? Formula will be Re minus S, which we had solved till now. Re means what? External support reaction. S means what? Equilibrium condition. Now if we have general loading, we will have S equals to 3. If we have vertical loading, we will have S equals to 2, students. Okay. Now we will solve certain question and you will find it very easy, and definitely in your AE exam you will be definitely getting almost all the questions correct by using this particular technique. Okay. Now the first question, students, which will exist here is like this. We will have a general load of 10 kilonewton here, acting at an angle of 30 degrees from the horizontal. Just find the external static indeterminacy here in this case, students. Very simple. This will have a vertical component in the downward direction. This will have a horizontal component in this direction. Okay. Now to balance this, we will have two reactions here, because hinge support will have two reactions. Okay, and fixed support will have three reactions: vertical, horizontal and moment. So what is the external support reaction in this structure? 3 plus 2. 1, 2, 3, 4, 5. That is the external support reaction. 5 reactions will be there. And in case of general loading, we know that we will have 3 equilibrium equation. So what is the value of external static indeterminacy? It will be we can write it as Re minus S as per our formula, and this will be 5 minus 3, which will be equals to, that is the external static indeterminacy of this beam. It means that it is a beam which is indeterminate to 2 degree. Okay. Now let's take the next case. This beam will have a load of 10 kilonewton in the vertical direction. Now tell me, what is the indeterminacy in this case? What is the degree of indeterminacy in this case? Simple. To balance this, we will have vertical reaction on both the supports and we will have moment on both the supports. Okay, we don't have any horizontal reaction because no horizontal load is acting on the beam. So total we have 4 external support reaction, and in case of vertical loading we know that only 2 equilibrium condition will exist. So what is the external static indeterminacy? This is Re minus S, which is 4 minus 2. Again we will have a beam which is indeterminate to second degree. Clear, student? Very easy question, very easy question. Now this type of question you will definitely find in your AE exam, definitely. Okay, next question. Now students, this is another case. Find degree of external static indeterminacy. So we will have one vertical component of this load, we will have a horizontal component of this load. So we will have vertical reaction on both the supports, we will have horizontal reaction on both the support. Moment will not exist here because it is a case of hinge support. So what is the value of Re here? 4. And what is the value of equilibrium equation here? In case of general loading we will have only 3 equilibrium equation. So what is the value of DSE here? Re minus S, that is 4 minus 3, which will be equals to 1. So this beam is indeterminate to 1 degree. So these type of question you will find in your exam. There are certain more complicated question which will exist in this particular topic, such as internal hinge question. We have to find one more thing here, that is DSI, and another thing that is DK, that is internal static indeterminacy and kinematic indeterminacy. And we have to solve, till now we had discussed only beam, but we had to solve the frames as well as the trusses, and we have to find the stability of these structures. Okay, students, if you just like this demo, okay, try to ensure that we have to cover almost all the things. Okay, so register as soon as possible, we will meet in the first session and we will discuss all the concepts of structural analysis, that is the indeterminacy portion completely. Okay, so I hope that you like this particular session. We will definitely meet in the next session where we will discuss all this concept in detailed manner and we will cover frames as well as truss also. So thank you everyone, thank you for watching this demo session.